So we've had an assignment we've been working on called Exponent Laws, and I've got the paper here somewhat organized like it is when you do it online. So you can see on the left-hand side I've got the directions for everything, and on the right-hand side then I've got the questions. Some of the directions are actually on this right side as well, but we'll just go through. Notice what, make sure you send this in when you get it done. And so this is actually part of page 2. So we're going to start right there with question 1. So hopefully you can see all that. So if we look on the left-hand side, I'm going to blow this up. Make sure you guys can kind of read it as I'm going through it. So on our screen here, we're just going to read through what it says, and we'll try and answer the question. So you've been using exponents for a while. Here's the first 6 powers of 2. So here's the powers of 2. 2 to the first, second, third, fourth. So it's going up by 1 here. And then on the right-hand side, 2 to the first is 2, 2 squared, 2 cubed. And notice here, each time it's going times 2. And times 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And they want us to find 2 to the 7th. You can see it right there. And so it'd be 64 times 2. And so that's what we're trying to look for here. And we're trying to come up for a rule. The rule that we come up with should calculate the next power of 2, such as 2 to the 7th, based on the previous answer, 2 to the 6th. And so you can see, you take 2 to the 6th times 2, okay, and you get 2 to the 7th, or you get 64 times 2, which equals 128. And so you're always taking the previous number times the one behind it. So let's see if we can answer this question now. So if I was asked to figure out 2 to the 7, I would do it by taking 2 to the 6th times 2. And then more generally, how do you get from one term to the next? The next term is equal to previous term times 2 would be a great way to express it in words. And so now we want to write an algebraic expression to represent this rule. So let's just make a few of these. So 2 to the 5th, for example, would be the previous term, 2 to the 4th times 2. And 2 to the 6th would be the previous term. And 2 to the 7th would be the previous term. And so look at what is going on here. It's going 5 for your exponent, so you use the exponent 4. And then take that answer times 2. And here the exponent was 6, so you start with the exponent of a 5. And so in our general rule down here, if I start with, let's use a b for the base instead of a 2. Actually, let's use 2's. It says use 2 for the base. So we'll go 2 to the n. That's the one I'm trying to find. How would I find it? I want the previous one, which would be n minus 1. So if my n was 7, n minus 1 would be 6. And then times 2. So there's our general rule for accomplishing finding the next power. In question 3, the diagram is shown over here. So let's get this thing organized again. In question 3, the diagram of 2 to the 5th times 2 to the 3rd shows. So here's the diagram. And you can see they've got 2 to the 5th, which is 2 times itself 5 times 2 to the 3rd gives you, and you can see it gives you 2 to the 8th. So in the diagram, what can we put there? We say, well, it gives us an 8. And you can see they just added basically those exponents, and that's going to be our next rule. Okay. Use a similar drawing as in the text, and let's figure out what this is. So you remember all those 2's lined up, so I'm going to line up all the 10's. There's 10 times 10 times 10, that's my 10 cubed, times 10 to the 4th. And so we can see we end up with 10, and I got to write it now 7 times 4, 5, 6, 7, so it equals 10 to the 7th. So again, adding those exponents. So if we had a general rule that we had to write now, pause back there for a second. In fact, let's go to a few. So 10 to the third times 10 to the fourth equal 10 to the seventh. 10 to the fifth times 10 to the, let's do 3. Would be 5 of them, then 3 more, so it gives us a total of 10 to the 8th multiplied together. So if it was some base to some power times some base, the same base, to another power, and you can see up here to get that 8, they did 5 plus 3. And so for us, we have an n and an m, so ours would be b equals n plus m. And that would be how you multiply with exponents when you have common bases. Okay, so that's what our rule looks like. Put that whole thing in there. B to the n times b to the m equals b to the n plus n. Show how your answer in question 2. In question 2, our question 2 answer was this: 2 to the n equals 2 to the n minus 1. Show how that works or compares to, or is a special case of, b to the n times b. Oops, I forgot part of mine up here. Okay, so we're supposed to show that these two rules, this first one from question 2 and this new, more general rule, that they are really consistent with each other. And to do that, I would just take a look at 2 to the n minus 1 times 2, the right-hand side of this. And I would apply this law. And so if I'm using the law b to the n times b to the m, it would be b to the, well, in our case it's a 2. It would be 2 to the n minus 1 plus 1, because we got this exponent and this exponent. So that's our b to the n plus m, and that just equals 2 to the n. And so this rule right here that we came up with 2, it's the same rule as this, except the base is 2, and one of the exponents is just a 1, and so it doesn't show up. So it's the same rule, just a specific case. All right, so let's move on here. Try and speed this up. Question 7, write out 3 to the 7th over 3 to the 5th, just like it was done with 2 to the 5th times 2 cubed. Okay, expand the exponents into big, long fractions. And so we can see we got a fraction, and then cancel out like factors on the top and bottom. So let's expand it. 3 to the 7th looks like this. That's our 3 to the 7th. Then that's all divided by 3 to the 5th. Say right 3 to the 5th. And now I'm going to cancel out like factors. These are all factors because that's what multiplication means. And you can see we end up with 3 times 3, or 3 squared. And so 3 to the 7th over 3 to the 5th gives us 3 squared. Why? Because of all this canceling that goes on. Right. So what does your drawing tell you about 3 to the 7th over 3 to the 5th? What is the exponent here? Well, that must be a 2. You can see it right there. General rule for this, and you can see what's going on here, 7 over 5, or 3 to the 7th over 3 to the 5th. Well, the math that's going on is you're just trying to find the difference between those two, because that tells you how many you have left in the numerator in this case. Okay, so it's a subtraction. So if we start with b to the m over b to the n, the answer is b. In our case, it was a 3 up here, to the m minus n. Subtract the two exponents. We already had a rule for division. We had this rule where you just subtract them. Question 4, we're supposed to do the same thing here with 3 to the 5th. So now it's upside down. I got 5 on top and 5, 6, 7 on the bottom. Again, we cancel. And this time, make sure I get the 3's lined up there. You'll see we get 3 times 3 in the numerator. So what's in the denominator? So what's in the numerator? Well, these 3 over 3's, that's just 1. So you get a 1 times 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 this 3 squared in the numerator. So you just end up with a 1 in the numerator. So that's 1 over 3 squared. Notice 3 to the 5th over 3 to the 7th equals this. So now we got that 3 squared, but it's in the denominator. So our general rule for this one would be b to the m over b to the n equals 1 over b to the n minus n. And so when we had b to the 7th over b to the 5th, I guess these were 3's, it'd be 3, oops, flip that around, do it the exact way we have it up here. 3 to the 7th over 3 to the 5th, if we did it upside down again. There we go. We get 1 over 3 to the 7 minus 5. 1 over 3 squared that way. Okay, so here's our rule for division. But now, see, we got a problem. That's what question 12 is trying to address. Because if you, and we have this rule now where you subtract them, but you're in the denominator. It should be an n down there, not a 3. An m, actually. And so how do we decide when to use that rule? And so here I'm going to put them side by side. Here was the first one we did. Gave us 3 squared. And here was the second one we did. Gave us 1 over 3 squared. And so the key is looking at these exponents. Let's call our exponents m and n like we've been doing. So if m, the numerator's exponent, is bigger, then you just subtract them and keep it in the numerator. But if the denominator's exponent is better or bigger, so now n is the big one, so now it goes like this, and you do n minus m down there. So it depends on whether the exponent is bigger in the numerator or denominator, and then you use the according rule. Let's now simplify this thing. So we got this big long expression here, but notice it's all multiplication. Okay, and so remember, multiplication is commutative, so this is the same problem. And we can just apply some of our rules once you make it look like this, or even mentally you can do it right here. Here's our common basis, so that's our first rule. This is like having x times x times x, and then 7 more of them that you multiply, and you end up with a total of 10 of those things. So there's the addition rule when you're multiplying with common basis. And that brings us to this equivalent statement. So the 3 plus 7, we add them up, and that gives us 10. And that's that rule, x to the m times x to the n equals x to the m plus n. Okay, now we've got some division problems. So we got our x to the 10th over x to the 5th. That's this rule. And remember, it has 2 outcomes. If the m is bigger, we just subtract them and keep it on top. And you can see the 10 is bigger here. So that x is going to stay in the numerator, and it'll be just whatever 10 minus 5 is. We do our y's the same way, but this time when we subtract exponents, the bigger one's on the bottom. So our answer ends up on the bottom, and we still subtract exponents. And so we just get x to the 5th over y squared for our final simplified answer. That should get everything up to that point done. We got 1 page left. There we go. All right, so now we're on to question number 14. We're going to raise exponents to exponents. And you can see we got 2 to the 3rd, then raise the whole thing to the 4th. And so 2 to the 3rd is 2 times 2 times 2. When you raise it to the 4th power, it means multiply it times itself 4 times. So here's 2 times 2 times 2, taken times itself 4 times. So we've got 4 groups each group with 3 in it, giving us a total of, and you could count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or you could remember the shortcut. If you got 4 groups of 3, just take 3 times 4 and it gives you 12. And that's our first answer here. Okay, so let's go ahead and expand this 10 to the 5th the same way. There's 10 to the 5th. If I'm taking it times itself 3 times, and I've used parentheses here. You could just put another dot between them. Oh, there we go. And that equals, now I just have to write them all out, and you can see dot, 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 10 times 10. It's going to give me a total of 3 groups of 5, so 3 times 5, 15. So 10 to the 5th to the 3rd. It's 10 to the 15th. Let's write a general rule for this, and you can see how it's set up. B to the m raised to the n, power to a power, exponent raised to an exponent. We get b to the m times n, or just b, m, n is how we write it. And that's it.